All right, this is Tolbert Physical Science, lesson number 3. Tolbert Physical Science, lesson 3, and this is also chapter 10. So, how do you express these chemicals? Chemical formula and chemical symbols and numbers, they indicate how many atoms are contained in a substance. Okay, so let's break this down a little bit. So, the chemists keep track of combinations of atoms by using these chemical formulas. We also call them molecular formulas. Molecular formulas also show the exact number of atoms each element has in the smallest unit of that substance. The elements occurring in the molecule are listed by their chemical symbol, with subscripts showing how many atoms of the elements are represented by each molecule. So you might have seen this before, of course, because every time I've talked about water, H2O, the H and the O are the symbols, the 2 is the number in the subscript. This here is a molecular formula or a chemical formula for water. So in a way, the molecular formula is a concise expression of how many atoms of each type are represented in a molecule. Here we have CH4, 1 carbon, 4 hydrogen. And then next to it, we have C2H6, where there are 2 carbon and 6 hydrogen. Miscible. Miscible describes when 2 or more liquids are able to dissolve into each other in various proportions. Liquids can fully mix together. The other mixtures we were talking about are more like mixtures of solids, but here we're talking about mixtures of fluids or liquids. Miscible is just referring to liquids when we're mixing with other liquids. So gasoline is an example of a miscible liquid. It has tons of other liquids dissolved inside of it. Immiscible describes 2 or more liquids that do not mix together. The great example of this one would be oil and water. Immiscible is just referring to liquids not mixing. So oil does not mix with water. Both are liquids, and they are called immiscible if you're trying to mix them together. Here's what you need to know. You need to know this about kinetic theory. All matter is made of atoms and molecules that act like tiny particles. These tiny particles are always moving. The higher the temperature, the faster they move. Also, at the same temperature, the more massive particles are moving slower than the less. So if they're bigger, they're going to be moving slower at the same temperature. Temperature. So there are 2 common scales. One of the ones that we use in America is Fahrenheit, where water freezes at 32 degrees and boils at 212. But the one we like to use in some science situations is Celsius. Also in America we use Celsius. Here water boils at 100 degrees. This picture is showing the comparison between water boiling on Celsius and water boiling at Fahrenheit. Alright, this is one that you'll need to know. This is the temperature scales. You'll need to know some of these in comparison. Here, on the left you have Fahrenheit, and on the right you have Celsius. Water boils at 100 Celsius and 212 Fahrenheit. Here's what your body temperature is. Your body temperature is 37 degrees Celsius, while it's 98.6 degrees Fahrenheit. Water freezes here 0 degrees and 32 degrees. Now, what you need to know, the difference between the two is the Fahrenheit scale and the Celsius scale. There seems to be more notches, okay? There's more digits, so to speak, in the Fahrenheit scale as there is in the Celsius. Celsius started at 0 at water freezes and moves up to 100. Alright, this is the end of lesson 3, and this is something that you need to know. You'll need to know how to convert these things. Alright, now you can use the formula here for Fahrenheit or Celsius using the 9/5 or the 5/9. But if you're using a calculator, I would definitely just go ahead and use this. If you're looking for degrees in Fahrenheit, you'll just take your degrees Celsius times 1.8. Or if you look in degrees Celsius, you'll multiply that after taking 32 by 0.56. Or if you're finding Kelvin, all you do is take your degrees in Celsius and add 273 degrees to it. You need to write that down because that is the quickest and easiest way to punch that in your calculator. All right, thank you for listening today.